Okay, geometry, this is the second video that we're going to have for this online assignment thing. This will be for online assignment number 2, which is a quiz that you can find under the quiz tab on my Canvas classroom page. Before we get started, we got to review just a little bit. First of all, Pythagorean theorem. It applies to right triangles where A and B are the lengths of the two legs, and of course the opposite of the right angle is the hypotenuse, and that would be C. And I also wrote here the 3 different ways you can write that equation. Hopefully we remember that pretty well. We might need that today. In fact, we probably will. Let's talk about what we talked about last time, which were these 3 area formulas. Let's see. Rectangular parallelogram, they both have the same formula. So whenever you're trying to find the area of a rectangle or the area of a slightly angled rectangle like a parallelogram is, you can use that formula. For a triangle, you have to use 1/2 base times height. Remember that the height has to make a right angle with the base. That's all that's important there, as well as the parallelogram as well. It's got to make a right angle if you're measuring that height. Okay. Trapezoid is also one that we covered. Remember that for a trapezoid, your base 1 and base 2 are going to be the 2 parts that are parallel. So let's see, we would call this B1 and B2. And remember that the height still has to make a right angle with one of the bases, or both of the bases actually. Okay. Then for a kite or a rhombus, let's see, that's what's going to be new today. Let's review just a little bit. This formula is for a kite or a rhombus. That's actually new, that's not review. But what I would say is, at least for reviewing, taking a screenshot of this screen right now would be pretty helpful to you. It has all the formulas you need for the entire assignment. Let's remember what a kite and rhombus is right after we test out this problem. There's a problem very similar to this one on the quiz. So I'll put on quiz. Very similar to this one. And what it is, obviously, is 2 triangles. We can highlight those triangles here and here. So we have 2 triangles, and we know that the area of a triangle is 1/2 base times height. The only issue is, I don't know what the bases are for these 2 triangles. I know that the entire bottom is 25 meters, but I have no idea what those bases are. So we're going to have to figure out how to get around that. And the perfect way to get around it is to notice that the heights of the 2 triangles are the same. What this means is, if we draw another dotted line up here, we can see that we actually have a 15 by 25 rectangle with a triangle that's cut out of it. So let's actually mark that triangle and just keep track of it. So this is all empty space. So we want to actually find the area of the rectangle. So I'll put area of the rectangle minus the area of that triangle, and I'll put that in green as well. So we want to subtract that out. To find that, we just have to notice that this 25 meters is going to be the base of that triangle. And if we were to draw an altitude, that height would just be 15 meters. Okay, so area of a rectangle is just base times height. So that is just 25 times 15. And the area of the triangle is going to be 1/2 its base times its height. So this will be minus 1/2. The base of the triangle is 25 and the height is 15. Okay, if we pull out a calculator, let's see if I can get that up. Pull out a calculator real quick. Ooh, there we go. 25 times 15 is 375 minus the same thing but divided by 2. So 187.5. Okay, so the area of the entire thing is going to be, I'm pretty sure 187.5, because that's half of what we started with. 375 minus 187.5. Oops. 375 minus 187.5. Yep, it's 187.5. Oops. Meters squared for for this problem. Okay, so that's just to help you on one of the problems on the quiz. Hopefully it won't trip you up too much. Let's also remember, I mean, I know we went over quadrilaterals, but it's been a while, so let's actually remind ourselves what actually is a rhombus. Okay, a rhombus has two diagonals. Specifically for a rhombus, the two diagonals segments actually bisect each other. So let's write that. Diagonals bisect each other. Okay, this doesn't mean that the diagonals are congruent to each other. It just means that, let's say that if this part was 7, then this other part over here would also be 7, and vice versa. If this was 5, that would also be 5. So we can use that when we're solving these problems. And what we're going to do is call this red line diagonal 1 with a D1. Just like when we were doing the trapezoid, we use B1, B2. We're going to use diagonal 1, and this will be diagonal 2. Now, the entire diagonal is the entire length of those lines. Okay, so in this specific case, let's see, in this specific case, D1 would be 5 plus 5, which is 10, and D2 would be 7 plus 7, which is 14. So that's just an example of how you have to add those up to actually use them in the formula. And the formula is actually quite simple. It's just 1/2 times D1 times D2. So in my example, it would be 1/2 10 times 14. And it doesn't really matter what that is. It's just, for this example, that would be the numbers we would plug in. Okay, a kite is actually very similar. It has two diagonals. Let's label them D2. I'll use the same color coding here. Let's call them D1 and D2. And you'll notice that D2 is bisected, but D1 is not. So only one of the angles only one of the segments is actually bisected here. So we can't actually just add up two different parts. I mean, we'll still, if this part was 3 and this was 7, D1 would be 10. Okay, and if they only gave us this part for D2, like if they said this part was 5, then we would know that D2 would have to be 5 plus 5, which is 10. Okay, but that's just an example. Those numbers actually don't make sense now that I write them out. Anyways, formula, actually the same. So that's convenient enough, at the very least. Okay, in the next part of the video, we're going to look at some example problems that are going to help you on your quiz assignment. Okay, example number 1, find the area of the rhombus below. I went ahead and already wrote out the formula. Once again, you should have these formulas next to you when you do the quiz. It'll make it a lot easier. And I would also have Desmos up in another tab so you can do your calculations pretty quickly. Okay, first thing I'm going to notice is that it says it's a rhombus. And the reason why that's important is because they didn't give me every single part that I needed. For example, they gave me that this segment right here is 7 meters long. And they gave me that this segment was 4 meters long, but they didn't give me anything other than that. So to find D1 and D2, we have to make some assumptions. Since I know it's a rhombus, I know that these two segments will be the same. They'll be congruent, okay? And so will these two segments. So that means that this part has to be 4 meters. And that means that this section over here has to be 7 meters because they're congruent to the other parts of the diagonals. So actually, we could say that D1, let's say that that's 4 plus 4, which is 8. And let's say that D2 is going to be the other diagonal, which is 7 plus 7, which is 14. Okay, all we have to do is plug those into the formula. 1/2 8 times 14. Okay, and pretty quickly we can do that by just taking 8 times 14 and dividing that whole thing by 2 to get 56. Area is going to be equal to 56. My units are meters, and since it's area, it's meters squared. Okay, for the next example, it's also a rhombus, so I'm going to write out the formula that we've been using, D1, D2. Okay, and the first thing you'll notice is we can use the same trick as before to figure out that this segment is 3 centimeters, and therefore we can also figure out that we can figure out one of the diagonals straight away. D1 is 3 plus 3, which is 6. Okay, so since we know that, what we can do is plug in the value for D1, but we're left with a conundrum here because we don't know anything about these two parts other than the fact that it's bisected by D1. other than that, we don't know anything about it. So we have to use some deductive reasoning. And what I want to do is actually highlight this triangle right here. And what's interesting about this triangle, if I redraw it, okay, is that this triangle is a right angle triangle, or at least it should be. My picture's not as good, but oh well. Okay, we know that part is 4 and that part is 3, and that's why in the beginning of this video we reviewed a little bit of the Pythagorean theorem, because we could think of this as A, B, and C. The hypotenuse has to be 4. Remember, that's the important one. That one matters where you put it in the equation. So knowing this, we can actually just plug it in to the Pythagorean theorem. A squared plus B squared equals C squared. If we plug in 3 for B and 4 for C, we can start to solve this. A squared plus 3 squared is 9, and 4 squared is 16. Okay, if we subtract 9 from both sides, this is why it's important to have scratch paper while you do these. If we subtract 9 from both sides, we get A squared is equal to 16 minus 9, which is 7. Take the square root of both sides, and A is going to be equal to the square root of 7. Okay, now for at least for this assignment, what I'm going to do is I'm going to leave this as a radical. Yes, you could take the square root of 7. You could take the square root of 7 and get approximately 2.646. But I've actually made the Canvas quiz so that you can round it at the end, or you could round it right now and you should still get the right answer. Either way, I know that this segment right here is the square root of 7. Okay, if we take D2, that has to be 2 times that. So it has to be the square root of 7 plus the square root of 7, since those two parts are congruent. So D2 has to be equal to 2 times the square root of 7. Okay, using this information, okay, let's highlight what we've done. We found D1 over here. That was really quick. We had to do a bunch of Pythagorean theorem to find D2. But essentially what we have is a way to work this out. Now, we can round now or we could round later. It does not matter. Okay, let's find this area. Area is going to be equal to 1/2 D1, which is 6, and D2, which is 2 times the square root of 7. Okay, 1/2 times 6, if we combine those two terms, 1/2 times 6 is just 3 times 2 times the square root of 7. Okay, which means that the area is going to be 3 times 2, which is 6 times the square root of 7. Okay, now this is the exact answer, but we want to round to 1 decimal place for the Canvas assignment. So we just take the square root of 7, I'll just redo it, square root of 7 times 6, and we get 15.87. So let's round that to 1 decimal place, so that'll be 15.9, and this will be centimeters squared for our final answer. Okay, and I think this will be the last example I do, since kites tend to be a little bit easier than rhombuses to deal with, mostly because most of their components will be labeled, at least for this Canvas quiz that we're doing. Now, next week we might introduce some trigonometry into these kite problems, but for now, this is all you really need. Once again, formula is the exact same. 1/2 D1 and D2. And you might be wondering, does it matter which diagonal I pick to be D1 and which diagonal I pick to be D2? And actually, it doesn't matter at all. The formula works out the same. Since you're multiplying them together, it doesn't matter what those numbers are. I got a lot of information. First of all, I know that for at least this diagonal, which I guess I'll call D1, I know that this segment is 8 inches and that segment's 14. So I could go ahead and figure out D1 is 14 plus 8, which is 22. Okay, for D2, let's highlight that. Okay, it gave me 2 congruent marks here and here, meaning that if this is 8 inches, this one is also 8 inches. So that means that D2 can just be 8 plus 8, which is 16. And let's put units on here, why not? 22 inches and 16 inches. You plug those in, we do a little calculating, and we should get an answer, 22 times 16. Now, whenever I calculate these, I always do the 1/2 at the end, just to make things simple to type in. 22 times 16 is 352. We take that and divide it by 2, and we get 176 square inches. Okay, let's go over your assignment and talk about what you need to do. Okay, let's talk about the first assignment real quick. First of all, this first assignment is due by April 3rd, by the end of this week. Next week, I mean. I want to go ahead and congratulate all the people you see here who, shout out to them, who already completed this assignment. Great job. I have something else for you now. We'll talk about the assignment for this video here in a second, but just a reminder that you can open assignment number 1 by just going to this URL and typing in this code. Make sure that you enter your name, and also know that you can attempt this quiz as many times as you want. So really, I should see all 100s on here pretty soon. I'm hoping. 37 player attempts. I have 90 geometry students, so that's not very good. I need everybody to participate. If you don't participate, I have to make a call home, and that's just more work on me. I don't want to do that. Let's talk about assignment number 2. Okay, assignment number 2. As you can see, this is my teacher view on Canvas, so it's not going to look exactly like this, but what you can do is go to our course, which is first, second, and fourth period geometry, and go to the quizzes tab. If you go to the quizzes tab, you should see this assignment pulled up called Geometry Online Assignment number 2. It's a quiz that allows up to 10 attempts, and instead of being multiple choice, you have to enter numbers as your answers. I put a link to the formula chart and also a link to this video on this quiz. It can be taken up to 10 times. And there's no time limit, so you're allowed to have any tabs open. You could even have this video open if you need to. What I recommend is having scratch paper and a calculator. That's all you really need, and if you don't get it on the first try, you can just attempt the quiz again. Make sure you do this assignment. I hope you guys are going to have a good weekend. Hoping to see you soon, hoping on my last prayer here. We'll see what happens in the future. I will have a new video up Monday or Tuesday of next week. So make sure to look out for that and to look out for any new assignments posted for next week. See you guys later. Have a good weekend and a good day.